Hi everybody, it's me again. Today we're going to continue with our Tetris game. Now we have some values that would represent the game state. We'll do an int for the piece, the current piece that we're using. Set that value to 0. The current rotation, set that value to 0. The current position of the piece in the field, we'll have it at X position. Let's set this to our field. Set that to P field width. Forget the value. What did I use? Field width, okay. And field width divided by 2. That way we can just place the piece into the field in approximately the middle of the field when we begin the game. Y position. We'll set that to 0. And from that we can now concentrate on drawing the piece into the field. We're initializing the field with a piece, and we are going to use alright, so we have our piece. This code handle piece is a tetramino piece, so we are basically iterating over a 4x4 array, and we're adding the pieces to the screen here. If the tetramino piece is basically an X, remember these are the pieces from the other videos. If you haven't watched those videos, I suggest you go back and watch those videos prior to this one. And it will iterate over the tetramino piece. It doesn't care about the dots. All it cares about is the X's. If it sees an X, it's going to take that position of that X and place it into our screen. And here again is the same basic formula we use to place a two-dimensional piece to fit it into a one-dimensional array. We're going back and forth between two-dimensional to one-dimensional. We're doing a translation from a two-dimensional position of characters, like I mentioned in our earlier videos if you watched it. And you know how memory is allocated in the computer. I'm not going to go through all of that, but it's just contiguous. It's just one long contiguous block of memory, and we're doing the translation. All right, and the pieces in the field is how the piece fits in. It's it's the position that you want to place it into plus the position of the piece, and we're offsetting it by 2. Again, if you haven't seen the previous videos, it kind of explains this formula, which you'll see again and again. Here it is here, here it is here, and it's everywhere. Here it is again, here basically. Alright, so the pieces on this. Start without debugging. Alright, so the piece got aligned with the border wall, so something went wrong. So let's see what we can do about that. You see the piece in there? A. This determines that it's an A. I didn't explain that before. So we're using piece A. Remember the piece is 0 initially plus 65, which is puts it as 65 is the decimal representation of the ASCII value of A. So that's why that's there. That gives you us the A. Let's see. This is supposed to be field width, not field height. Yep, that's supposed to be field width. Let's try that again. Build. And run. Okay, so the piece is in there. Not exactly in the middle, but it's basically how it's aligned in the tetramino block. So we kind of got it on more towards the right side of the field. That's all right. We'll just leave it that way. And let's close this. So that's taken care of. Now it's important that we make sure that when you're moving the piece left and right, it's not crashing into things. So I'm crashing into the walls and all of that. So we have to make write a function to take care of that. And also you have to make sure that the piece actually fits. So before, remember, we are going to be rotating the piece. So we need to know, if I make this rotation, can the piece fit into its new position? And we have to check for those cases before we actually do the rotation and commit it to the screen.